All right, so we just went over an example of a linear system that has one solution or one point of intersection between the both of them, right? This one solution, or 3, 2, if we're looking right here over at our graph, that one point satisfies both of our linear equations right over here. All right, now let's look at one of the other possibilities for a type of solution we can have, and that is no solution. So no solution is when we have parallel lines. That's what we're looking at. We're looking at a system that is two equations that are completely parallel. These equations don't have a solution that they share. There is no point that satisfies both of them, right? There are plenty of points that you can plug in to satisfy this equation, but there is not a point that you can plug into both of them to satisfy both of them at the same time. So keep that in mind. And what that looks like graphically is just parallel lines, okay? And for our final possible solution outcome, we can have infinitely many. Now, this one's a little harder to visualize, but what infinitely many solutions mean is that you have two equations that are on top of each other graphically. So this is kind of hard to see, but there is L1 right here, okay, and there is L2, and both of them are on this line right here. Both equations fall on this line. All right, it's a little hard to visualize, I know, but and essentially what you're seeing is that every single point, I can pick a point, let me just do this, I can pick a point here, and that's going to satisfy both of these equations. I can pick a point here, and that's going to satisfy both of these equations. I can pick a point here. And these are going to go on forever. They're just lines. They go on forever. So there's infinitely many solutions. And we'll talk about when that's a case and what kind of characteristics you'll see with that. But just understand, I'll go ahead and write this out. So we can have what is no solution. We can have one solution. Or we can have infinitely many solutions. Now, one thing I do want to touch on very quickly is another bit of vocab in linear algebra. So when we talk about one solution, infinitely many solutions, no solutions, there's a way that we classify all of these, okay? And it's by saying something is consistent or inconsistent. And what we're talking about here is just a classification. So a consistent system, all right, is when we have 2 or 3 from our above list, or when we have one solution or infinitely many solutions. We say our system is consistent if there is at least one solution, all right? And now, conversely, our system is inconsistent when we have one from the above list or no solutions. All right, so when we have no solution, our system is inconsistent. In the next video, we'll go over another moving along, how we can kind of represent the systems very precisely, very concisely in a neat manner. And that's a big part of linear algebra.